Mohammed Hashemi. The series where partial discharge concepts are explained step by step. Today's episode is about test circuit for IEC 60270 standard. Previously, we discussed that one of the most common tools and technique for PD detection is electrical. And in this standard, the concepts, the definitions, and the circuits for PD measurement have been explained. The IEC standard covers the AC PD measurements up to 400 Hz and for DC systems. Maybe it is questionable for you why it is needed to perform the PD measurement up to 400 Hz. We should explain that sometimes you need higher frequency to mitigate the challenges of saturation of the magnetic core in power transformer. And you use 120 Hz, 150 Hz or higher levels. Sometimes you have line cables and it is not easy to provide the high voltage supply to provide the current of the test in high voltage and PD measurement. In this case, you can change the frequency of the measurement and the voltage that is applied to the test object. The frequency range might be changed to low frequency, similar to 10 Hz or 20 Hz, and the higher level of the frequency can be up to 300. Accordingly, the IEC standard should cover full frequency range of the voltage that are used to detect the partial discharge and for PD measurements. And for DC, there is this standard for detecting the partial discharge. Maybe in future, different standards or concepts should be developed because the phenomena and behavior of the partial discharge in DC system will be different from the AC system. We come back to the test circuit for electrical PD measurement that have been explained in the IEC standard. In the document of the IEC, you can find 5 circuits. Most of them are similar, only for the bushing and using the bushing tab is a little different from others. One circuit that you can use for PD measurement, and it will be useful to understand the connections and the tools for detecting the partial discharge electrically, is this figure or this circuit. You have high voltage supply, similar to the high voltage power transformer that you use in the laboratory. You apply the voltage by these systems, and it is AC in the frequency that I explained, like the power frequency, 50 Hz, or induced voltage test like the 120 Hz or other frequency. You have one filter that filters the signals and undesired events from the power supply to the test object and measurement site. If you have good filters, you will have better situation about the background noise and interferences. The background noise is related to the events that are not originate from the test object, and they are related to the environment or they are related to the high voltage supply for applying the voltage. As you see, you have a test object that is shown by CA. Previously, we discussed most of high voltage assets can be modeled by one capacitor because there are some dielectric between the high voltage electrodes and grounded electrode or different voltage levels that are separated by different insulation materials. In parallel to the test object that you have, you put one coupling capacitor that has been shown by CK. In series with the coupling capacitor that you have in the high voltage laboratory or in your test circuit, you put the coupling device, CD, and coupling device is connected to the measuring instrument by the connecting cable, and you capture the electrical PD signals. Previously, we explained to you that the partial discharge creates some currents or current pulses. The current pulses due to the partial discharge is observed by the coupling device. Coupling device or quadrupole is a 4-terminal network that converts the PD pulse current to the output voltage, and the measuring instrument detects the output voltage. Based on the output voltage, you can observe the partial discharge and you can report the partial discharge based on the IEC 60270. In next episode, we discuss about the output voltage apparent charge like the picocoulomb, nanocoulomb or others. It is necessary for you to know how the electrical PD measurement system works. Today we discussed about the test circuit for IEC 6270, and we explained different components that you have used in your test circuit, and you can use different commercial tools, and most of them use similar concepts. Maybe the configuration of the test object, coupling capacitor, and location of the coupling device will be different based on the 5 test circuits that you have in the IEC standard, but the concept of them will be the same. Thank you for watching. We'll see you in the next episode.